The exciting title of this talk is How I Spent My Summer Vacation. This is highly relevant to Varnish, surprisingly. I'm not going to explain to you how Varnish works. I assume you know that. I'm going to talk a bit about how we're going to make sure it keeps working. The HTTP protocol is a very pure request-response protocol. The client, the web server, whatever, sends a request, it gets a response. And in theory, it is stateless. In practice, it is not, because people lumber a lot of cookies in there. But this is what allows Varnish to run very fast, because we only have very small time slots where we actually need to care about each individual client. Most of the time, for a given TCP connection, Varnish just sits around waiting for the client to send the next request. So we allocate a lot of resources while we work, and then almost no resources while we wait. Allocate a lot of resources to do a request, release them again while we wait. This gives a work pattern that consists of very small spikes of CPU and resource usage for one individual client. And that means we can fit a lot of clients in on a single machine. It means we can do a lot of requests on a single machine because they're very light and easy to do. That's what makes Varnish very fast for HTTP. Technically, this is called a high-aspect farm-friendly job. Or as Arthur prefers to say it, on average, Varnish doesn't do shit. The design scenario for HTTP, and now we're talking something that's like 30 years back, is that you would open a web page and you get one, maybe two or three objects back. You'd open the Dilbert web page. That's actually the first web page I ever opened. And you'd get a Dilbert cartoon. Some HTML around it and a Dilbert cartoon, and that was it. No ads, no JavaScript, none of this stuff. Today you get, probably not by accident, 42 objects when you go into dilbert.com. And this is a problem because it takes time. First of all, there's a bunch of cookies you send along every time. So that's bandwidth, a couple of kilobytes each time. But more importantly, we have to turn around the TCP connection all the time. 42 times in total, actually. And if the web server for dilbert.com is on one side of the planet and I'm on the other side of the planet, that takes time. If I'm using a mobile phone, that takes even more time because mobile networks are slow. They may have high bandwidth, but they're slow, they have a long delay. So this is obviously something that people are trying to address because this affects the user experience. You type dilbert.com, how long time does it take until you have the page rendered in your browser? That's a very important user satisfaction parameter. People have examined how long time users will stay on a site. And it's like, if it takes more than a couple of 100 milliseconds to render the page, they'll do something else. That probably says a lot about how interested they were in the first place. But it is an interesting thing to optimize for because there are applications where this is important for other reasons. Not everybody is sitting behind a browser. We're also using HTTP from program-to-program communication now. So the creativity boundary for doing something about HTTP is first and foremost the speed of light. Until we find a good and sensible supply of dilithium crystals, we're just going to be stuck with 300,000 meters per second. There's also some other invariants which people tend to regard as unchangeable. For instance, the fact that we use TCP/IP. There's a very good piece of work done on a protocol called SCTP, which is a very, very, very smart protocol. It allows you to open connections using multiple different paths, and it will kind of use the best one at any one time. You can change IP numbers while you have the connection, stuff like that. Very brilliant work. And of course, nobody's using it because it's not TCP/IP. TCP port 80 and 443 are also kind of sacred in the sense that they are hard-coded, compiled into even a lot of web appliances, firewalls, gateways, parental consent filters, all that sort of stuff. A lot of that simply doesn't work if you don't run on port 80. Try to create a website that runs on port 81, and you'll notice that most of your neighbors will not be able to access it because they have various filters and antivirus and crap that says, oh, this is probably malware. So port 80 is the big hole and everything else is closed. Very often, surprisingly, 443 is also closed because you can't see what people are doing on it because it's probably encrypted. There are legal requirements for being able to see what certain people do. But in general, the web is far too paranoid. I'm not going to start a rant about antivirus here, but I'm not a fan of it. The other thing that seems to be invariant is the HTTP, CSS, JavaScript model. It's not very smart, objectively seen. There are better ways to design a page renderer, and there's better ways to transfer data. But right now, that's the model we have, and people seem reluctant to change it because a lot of people have invested a lot of time writing JavaScript and style sheets and so on. But in theory, we could change these if we found something that was better. So the first thing people are looking at in the HTTP2 context is doing pipelining and multiplexing. So we'll go to dilbert.com, we'll get the page, and then we'll say, oh, we're going to need all these objects, so give me all of these. And then the other end sends them to us as they become available. The one big advantage of this is that we don't need to turn around the line so many times. We have a turnaround to get the main page, and then we said, we need these 42 objects. And the other end turns around the line and sends them to us. We can also do some savings here by not sending the cookies every single time. So this is sort of the level 1 of what can HTTP 2.0 do for us. But it's not really very satisfactory because it doesn't solve the real problem. We still have a lot of we still have the first turnaround. We're not gotten rid of that. So people have come up with this thing called server push, which is where you go into Dilbert's homepage and you get Dilbert's homepage. And then it says, oh, by the way, you'll also want my style sheet and you'll want all this graphics. So the server starts pushing objects on you before you've asked for them because it just knows you're going to need them. And this cuts the overhead down to practically nothing. But it gives a lot of problems. For instance, if there's a cache in the middle that already has these images stored, this is a waste of bandwidth. So there needs to be some way to say, yeah, I have that one, don't send it to me again. So we don't really save the turnaround because it says, oh, you'll also want these objects, but tell me if you don't anyway. And the reason why server push works in Speedy is because Speedy is built for end-to-end connectivity. They use TLS to make sure they have end-to-end connectivity to get all the telcos out of the data and stuff like that. And in that case, there are no caches that might have these objects. So they don't have the entire issue of intermediaries. I don't think server push is going to make it into HTTP 2.0. It's just my feeling for it, but time will show. There's also a political wish list for HTTP 2.0. There's a lot of people who want to make encryption mandatory because we want to get everybody out of our data. We want to have end-to-end privacy, yada, yada, yada. That is a very heroic goal to set. There's only a couple of details. It kills any kind of caching in the network because you only have end-to-end connectivity. And there's places where there's simply a legal mandate to inspect. In certain countries, inmates in jails are not allowed to have secure communications with anybody but their lawyer. Everything else has to be inspected. And we can talk human rights and decide whether this is the way it should be or not. But that is the way the legally instituted government of those countries have decided it's going to be. And if that's going to change, then their population will have to change their government. It's not something we can do with a protocol on the internet. That's not how it works. Also, there's a lot of places where parents insist that kids don't see playboy.com. My personal take on that is that playboy.com is one of the better sites for them to see if they have to see any of those kind of sites. What happens if you don't offer a way to do legal inspection is that people do it anyway. Then they will put up a proxy with a bogus certificate, and they'll pre-install it on all laptops, on all computers in the company, so they trust the proxy. And then what happens is, you think you have a secure connection, and you do, all the way to the proxy, but not from there on. So you protect the bit onto the company gateway, but not the bit across the big bad Ethernet. A lot of people are surprised they can't access PayPal, eBay, that sort of stuff, because they don't take non-protected. But it says protected. Yeah, but look at the certificate. You're protected all the way over there. These bogus certificates is a major security problem. If you look through the certificate list in your browser, if you have not weeded that out, you should. I'm sure there will be root certificates on there from places where you're like, no, I don't trust these guys. Some of those certificates are not just suspect, they're decidedly bogus. And some of those certificates has been used to issue what's called a wildcard certificate, which means they can impersonate anybody on the net using your trust in a Chinese root certificate and stuff like that. So certificates is a problem, and we shouldn't do something that makes them a bigger problem, in my opinion. For now, the mandatory encryption issue has been killed. We've done that, I think, 3 times this year so far. And like a zombie that won't die, it keeps coming up. Every time somebody new joins the working group lists, it's like, oh, and what should do, man? It's just a bad idea for a lot of reasons. You don't want to make everything secure, because then people will not be able to tell when things really need to be secure or when things really are secure. Stuff like that. Session IDs is a wish list item, amongst other things, from me. The way we use cookies now is as session identifiers. We don't have a session identifier in HTTP. So we use cookies. We tell the client, next time you contact me, give me this one back. And since we can't trust the client to not fiddle with it, we have to use some strong crypto on our cookie so that we can, when we get it back, we can see it's actually valid. To actually use cookies safely, you have to sign them with a certificate so that you can check when they come back that they are signed with a certificate only you have. Because otherwise, people will edit them and send them back just to see what your web shop will sell you. There's still web shops out there where you can put things in your basket, then you can edit the cookie, and then you can buy them for nothing because the price is encoded in the cookie, in plain text. Right. Cookies are a bad idea. It moves the cost of keeping session state onto the client and leaves it dangling there forever. If you look at how many bytes your average browser spends on cookies because you once visited a site somewhere in the eastern Elbonia, and the cookie's still there. It would be a better idea to introduce a session identifier. So the client says, hello, here's my magic cookie. This one identifies me, nobody else has it. And have the server side store what's in the basket and so on. It will also save a lot of bandwidth. And would actually give people a way to do private browsing, because when I do private browsing now, it will create a new session identifier and never use it again. So even if you have an existing permanent session with BBC homepage, you can do private browsing and it will create a new session identifier for you, and they will not be able to match them up except for IP numbers and so on. It would be a nice thing, but a lot of people have a lot of time and effort invested in cookies, so they're not very keen on changing it. It's probably not going to fly unless there will be technical requirements making it necessary. And the final thing is proxy HTTPS handling. It would be nice to be behind the corporate antivirus proxy and be able to get a secure connection to the proxy and a secure connection from the proxy to eBay or your bank or whatever. It means you have to trust the corporate guys and their proxy, but that's probably pretty easy for most employees to do. And it would mean that you've got a secure path with that one place where they can look at the content. Right now, the way proxy handling is done, you cannot do that. You cannot say get HTTPS : to a proxy and get it to work. And there's some interesting details about how you tell people that they are being intercepted, because you might hit another proxy further out that does the same stunt. And you need to have a back channel that says, are you going to trust this proxy with your banking transaction? And the user will have to type yes, no to continue the path. So that one is surprisingly tricky to do. But even if it just supports one stage of proxying, that would be a big advantage relative to what we have now. There's a technical wish list too. Things like we want to do compression. That's actually mostly about the cookies. Most cookies are base 64 or hex dumps of cryptographic data. And sending that as ASCII is a waste of bandwidth. Sending it binary would be better. Entirely getting rid of cookies would be even better. A better protocol serialization. The current HTTP protocol is actually pretty expensive to take apart. Load balancers, incoming load balancers, are the bottleneck right now. That's where all the traffic for a major website comes through and gets farmed out to a bunch of servers behind it. And it would be smarter to do something like we do with email and what we do with regular mail, and that you put a routing address on the outside, which is easy to find, and then all the details can go inside. So it might be an idea to make the HTTP2 protocol so that the host header and the URL and the method are encoded in a way that's very easy to pick out of the first number of bytes that comes in. And then a load balancer doesn't care about what your accept blar is. It just wants to know enough to say, I need to send it in that direction or that direction. And this is where we run into the SSL privacy thing, because putting an envelope on means you can see, oh, this guy sent a packet HTTP request to his bank. And the question is that actually secret information? In some cases it are. In some cases you don't want to know who you are communicating with, but they will always be able to see the IP number and where the packet goes, unless you start using the Tor network and stuff like that. So there's very little loss of privacy in adding, even to HTTPS, a routing header that makes it easy to find out where's this stuff going. And with the kind of bandwidth we're getting to, it may simply be necessary to do so, because finding the host header somewhere down in a HTTP block is bad enough. But HTTP 2.0 will probably not have the advantage that HTTP 1 has, because you can almost assume that the request will start at the front of a packet. There's a lot of load balancers, particularly the cheap ones. They will not work if the request does not start on a packet boundary and come in one packet. There are attacks out there where you fill in bogus headers so that some bit of your request comes in the next packet or split over two packets and stuff like that. And there are load balancers that will just croak on that. That will get a lot worse with HTTP 2.0 because we try to keep the pipe filled. So you will have requests starting in the middle of packets and stuff like that. And finally, there's right now HTTP headers are defined basically in ASCII code. And there's some people who want to use Unicode, legitimately so. But the question is, do we want the header names to also be able to be in Unicode? Should you be able to write host : in Chinese? Probably not. It looks like the serialization step will probably go to a enumerated type, so that accept encoding becomes 7 and accept language becomes 8, and you have an integer field saying what header it is. And that would actually take care of that one, but then you can always add extension headers, and they may actually be in Unicode. So here's a header you've never heard about, and it's in Chinese. Good luck with that. Apparently, HTTP 2 is not about the HTTP to HTTPS upgrade cost. Very often you go into a web page, you log in, and then it opens the HTTPS session. So you have to open a new TCP connection, you have to take a round trip, and so on. It would be neat if you could open an HTTP connection, and the web server in the other end says, you know, let's negotiate encryption right away, because I know you're going to need it in a moment, and have a multiplex channel where you use the overhead channel to negotiate the encryption, and then you can decide that channel 1, 2, and 3 are encrypted, and 4, 5, 6, 7 are not. So that, for instance, you can transfer the images unencrypted. There's no reason to spend encryption resources encrypting a picture of a lawnmower, but the transaction to buy one would be encrypted. Proxy multiplexing efficiency also does not seem to have registered with a lot of people in the working group. It would be very neat for a proxy to be able to multiplex secured and unsecured traffic on one TCP connection, rather than having to have two against each server for that. HTTP routers is a term I'm trying to coin. That's sort of load balancers and stuff like that only needs to look at a very small subset of the HTTP request and then send it in the right direction. We don't have a word that indicates a routing function. So we have gateways and stuff like that, but it doesn't really give the idea that we have something that doesn't care about the content. It just sends it in a particular direction. And apparently also the handling realistic future bandwidth is not very high on the agenda. I know one laptop that's coming out with a 10 gigabit Ethernet interface soon. It may not be available at your local shop. But there are people in high-performance computing that would like that. Because when you go into a data center, you may have 10 gig only switches and you can't plug in your laptop. 20 years from now, we'll probably have 100 gigabit Ethernet on our laptops by default. That's a lot of bandwidth. That's a really lot of bandwidth to deal with. And imagine being CNN.com next time something big happens. They're going to get hit with a terabyte of traffic. They will have a load balancer sitting there trying to distribute a terabyte of traffic to whatever they have behind that. Therefore, I think HTTP 2.0 should really think about making transmission efficiency and routing efficiency a high priority. I've had some positive feedback on it and a lot of blank stares. One person said, but Cisco will solve that. I was like, and then I have an email I printed out. It's from 1999. And it starts out saying, we really need to get on IP version 6 now, and this is really a high priority item. We don't want to be left behind. We haven't quite gotten to it yet. The problem for IP version 6 is that IP version 6 was not any better. IP version 6 didn't do anything IP version 4 didn't do. So why would you bother changing? It's like, oh, you want to take all this work to upgrade everything, and the advantage you get is that you get to do all this work. If you want HTTP 2.0 to be a success, it has to provide something that makes people change to it. It has to do something better. It has to do something drastically better. And it has to do that without raising the barrier. If you're required to have a certificate and pay protection money for it, HTTP 2.0 is not going to be a success. If you mandate an expensive encryption or expensive compression, the entire porn industry is just going to punt on it because they don't want to spend the effort encryption picture. They're like, who cares? Your wife knows anyway, right? So HTTP 2.0 has a very significant risk of becoming a dud. The fact that they've spent, I think, close to 5 years trying to clarify the RFC 2616 by expanding the size of the text by a factor of 3. It's still not, I think it's draft 20 or 21 just came out, and it's still not quite done. But that was a clarification of the existing semantics. So I don't think HTTP 2.0 is going to come out of the standards process anytime soon. In particular, not for a number of, should we say, procedural reasons. They have chosen to take the Speedy draft as the starting point. And the author of the Speedy draft is apparently one of the most hated people in that section of the internet. Whenever I say something about it, I get emails like, yeah, kill him. And people are like, yeah, I can't say this public, but can we get him banned from the internet and stuff like that? He's not a very popular person. And that's going to make the process even trickier. And the fact that we take this draft and we keep some of the headings and take the entire substance out and put something else in is not going to make it fast either. So don't wait up for HTTP 2.0. I wouldn't. But we still need to do something about in Varnish. We don't need to come up 5 years and say, oh yeah, oh HTTP, yeah, we should start looking at that. We want to be ready. But it's sort of like shooting fish in a waterfall, which is very hard. You have no realistic timeline for when this will happen, if it will happen, where it will happen, and we don't know what it will be. And it may not even be relevant when it comes out. Speedy may or may not be relevant in the meantime. It's very clear that they're not going to wait for the standardization process. So we may have HTTP 1, HTTP 2, and Speedy at the end of this. So what should ones do? Varnish could do a lot with this. Varnish would be a perfect place to do the conversion between an HTTP 1.0 application and HTTP 2 clients. We have the VTL language, which is perfect for expressing this kind of thing. You could say, oh, you're asking for this, here, push these things on him also and stuff like that. It would make a really good gateway between protocols. So at the point where we are now, we're very heavily optimized for HTTP 1.1. At a technical level, we have resource management that's built for this small aperture request handling. On a more architectural level, the way we lock transactions, the way we flow through the VCL are based on the model of HTTP 1 traffic. That will have to change. The place we want to end up is to be able to have multiple requests per session. And they have to be, I should probably put independent in there. And we want to be multi-protocol. We want to be able to handle different protocols. We may see, there's some rumors, a back-end protocol that's different from HTTP 1.1. A lot of CMSs are never directly on the web. They're behind something. And this is sort of like, yeah, we can sort of shortcut the HTTP 2.0 process if we do this. So some objects you would simply have blank objects you could pick, and you wouldn't get all the headers, because who cares about the headers? You know what it's going to do. And you'd have some kind of intelligent front end doing the translation. Varnish may play a role here. But HTTP 1, 2, and Speedy, and so on, we want to be able to do all of them. The first thing that's most obvious is that we need to decouple the client side and the backend side transactions. We want to have a separate thread doing the entire backend transaction. That introduces the problem of having a rendezvous between the threads. So you come in, you get a miss, you start some other thread picking it up from the backend, and you need to see when they get back and so on. So technically that's some interesting work. Not a lot of work, but there's some work, and there's some nasties to look at it. The main problem is actually, how does this look in VCL? There's some immediate payoffs of doing that. So there's good reason to do that now. For instance, we get a cleaner streaming implementation. We could start looking at parallel ESI fetches, so that you go out, ask for all the ESI includes right away, and then you deliver them as they come. And we could have a the grace mode we have now is that the first one gets stuck picking up from the backend, and everybody else delivered the stale object. With this, some other thread will go off, pick up from the backend, and everybody can deliver the stale object. So we don't have this one client stuck picking from the backend. So that one's pretty much, we'll do that. Multi-protocol is much harder. Multi-protocol is the protocol is what defines what a session is. A session could be one or more TCP connections. Right now, nobody's talking about parallel connections in one session, unless you go to look at SCTP, where that sort of happens. VCL is not prepared to handle it at this time. We mix the session aspects and the request aspects. For instance, you can insert connection close, which affects the session. And what would pipe mean for other protocols is something you need to define. One way to do this is to say for each protocol we have VCL functions. So we'll have a VCL receive for HTTP1 and for HTTP2 and for Speedy. Or maybe we just have VCL for the abstract request and the session handling just sort of happens by magic. That's a tough one. Right now we have a lot of code that relates to the session and the protocol, which is not the abstract request handling. All of this must be abstracted out so that you can replace it. There are some sort of APIs there now, but they're not really APIs, they're just more code structure. So that needs to change. For instance, accepting a connection. At the time we accept the TCP connection, you may not know what protocol is going to come down the wire. So you need some step there that can fork out depending on what you receive. If HTTP2 becomes highly multiplexed, as it looks like, then it may make sense to have a thread have a thread sitting there receiving stuff and farming that out, and have another thread sitting there sending the responses. And each of the requests gets their separate thread to do that request. Without knowing how HTTP 2.0 will look, that's kind of hard to predict. But it can become much more complicated. And we still want to be able to serve HTTP 1.0 at the same time. Doing this work has absolutely no payoff at this time. There's no payoff of being multi-protocol until you have more than one protocol. But it's a lot of work. So it's the kind of work where we'll quietly try to move in that direction as we work, so that we're better prepared once protocol number 2 realistically pops up. So expect to see weird things happening in the code that doesn't really do anything, but hopefully sort of paves the road. VCL language is the hard part. VCL is a domain-specific language, which means it's basically a toy language built to do one particular thing, which is deal with HTTP request. That means you have a strong expression of domain mechanics. Your objects relate to the domain you are in. You have requests, you have responses, you have headers, yada, yada, yada. And you handle a lot of the invariant details. For instance, you don't have to tell what kind of character set you use for HTTP headers because that's implied by the protocol. If you wrote in a language like Perl or Python, you would have to make sure you didn't accidentally stick Unicode in there, and stuff like that. And we also try to minimize boilerplate code. If there's stuff in VCL that everybody has to have in their VCL code, it should probably not be there in the first place, unless there is legitimate reasons for not having it there. You should not have to deal with how to accept a TCP socket because that's sort of implied in HTTP that you will accept a TCP socket, stuff like that. Unfortunately, VCL is also where you guys invest all your resources. So that means whenever I change it, I get yelled about. Changes has to be good to be welcomed at the users, and I am aware of this. But sometimes you have to break the eggs to make an omelet. And multi-protocol is going to change the VCL one way or another. I have no idea what it looks like. And we'll do a lot of mock-ups and prototyping to try to find out how to do it best. This is actually where I spend a lot of time thinking. Right now, we have a trend towards what I call magic buttons, and I don't like it. We have all these do gzip, do gunzip, do ESI, etc. I really don't like them, because they have a n-squared complexity. So what happens if you have do gzip and do ESI? It's hard to define what they should do together. And it's even harder for users to remember which ones go together and which ones don't. I would prefer a programmatic model in VCL. Unfortunately, that leads to more VCL code. So just as an example, here we have a purge where we do it with a magic button. We get a purge request in and we say, okay, set this magic button that says purge all variants of this one. And things will happen automatically and you can forget about it. That's a really easy one, except if that's not quite what you want. you get this one button to push, and if that doesn't do what you want, well, you're stuck. So we can kind of do a semi kind of mixed mode where you can go into add a new VCL lookup, and you go in there and you say, okay, I can purge all variants at this point because I've decided that I wanted to. And you can return a particular response. You get more control. Or we can go with the full programmatic model, where you come into VCL lookup and say, oh, this is a purge, so go through all the variants, and if the backend is healthy, you purge it, and if it's not, you just give it more time so that we still have a stale object to deliver until the backend becomes healthy. Now you get very detailed control of what you can do, but you have to write more code to do even simple things. That's going to be attention all the way through. We'll have to look at each feature and say, is this a magic button, or is this something we should split up into programmatic models? Some of them will get right the first time. I have to say that most of them I think will get wrong the first time, but then we'll change it. It's very important that you guys try to run the trunk version in your test environments and give us feedback on stuff like this, because otherwise we're just sitting there in a vacuum, not knowing what we're going to do. But I'm not going to ask you to decide, because I know what the response will be. So finally, thanks to the VML sponsors. They're the ones who keep my Varnish habit going. And hope we have fun. Hope we learn a lot from each other today, and for the developers tomorrow. So, questions?
London, we write the website, put everything into an API, and probably migrate away from Akamai. And in the manual it says 2 thread pools, which I totally get, and it says 5,000 limit per thread pool. We get about 1 million visitors an hour during the strike, snow day, bombs, something like that. Why is there a hard limit? Is that a definite hard limit? We're trying to spec out how much resource we need, how many Varnish boxes we're looking at. Any thoughts on that?
I don't believe it's a hard limit.
Okay.
I believe you can set it with parameters to pretty much anything you want. The parameters is a problem in their own right. We want the parameters to not screw anybody the first time they start Varnish. But if you're running big sites, you will have to tune them. It's sort of hard to find the works perfectly parameters. And that's also a place I'm very interested in feedback. If there are parameters where everybody changes away from the default, then the default is probably wrong. And we need to know that and improve it. But I don't think there's any limitations there. You can't increase to pretty much anything your machine can cope with. The code that's in trunk right now has changed drastically with respect to threads. We use, in 2.0, we have a workspace for the request, for the session. And we have one for the worker thread, which we use for backend requests. What we've done in 3.0 is that we have a workspace we have only while doing a request, and we have a workspace which we only have while doing a backend request. And the actual thread is much smaller. It has, I think I ran all the tests with a stack size of 40K or something like that. And that means you can have many more threads on the same machine. I've yet to see any apples to apples comparison what this does, but you shouldn't have a problem realistically with the number of threads anymore.
So it's just hardware constrained, basically?
I can't speak for your kernel. There are operating systems out there which has not quite caught up with this millennia yet.
Linux by default still has 32K max threads across the whole system. Max PID.
I didn't want to mention any names.
I figured I thought I'd do it for you.
There are other operating systems that's worse. And there are certain hardware platforms where it's actually a hardware issue.
There's VPS providers that only allow you to have 1,000 threads.
Use somebody else.
So you talk about multi-protocol support and now how you're going to prepare Varnish for new protocols that may come, but Speedy is already here, isn't it? And it kind of assumes mandatory SSL as well, as it is.
Speedy is here, but quite frankly, I think it's so brain damaged that I'm not going to implement it in this current shape. Basically what Speedy is a great prototype. Speedy has shown us that there is significant stuff to be harvested in this space, and that's why we're doing HTTP 2.0 in the first place. That's only because they did Speedy and they showed there is something to be done. But what they did was sort of, they wanted end-to-end privacy. Google has a political agenda that says they want telcos to be bit movers. And as a consumer, I can follow that. So they do TLS to get everybody else out of their traffic with the end user. But that costs an overhead. So what they do is they compress it before they stick it into TLS. So they have this special dictionary they use to initialize the compression, and they stuff everything in there and push it down the road. And it seems to do wonders for Google's traffic. But when other people try to use Speedy's compression, it doesn't do shit because their headers are not like Google's headers, and they don't come in the same order as Google's headers and stuff like that. So it seems that that dictionary is sort of Google's dictionary. And that's not a very easy way to mandate things on the web. There's some other issues about Speedy which makes it special purpose, I would say. So at this point, I'm not very interested in implementing Speedy because I don't think very many people would use it because it doesn't give them a net advantage. There's a new draft of Speedy out, a draft subsequent to the one that was adopted for the HTTP 2.0 baseline. I haven't read that one yet. They've gone to the point now where TLS is not mandatory. That gives them some other problems because they relied on TLS to do certain things for them. I haven't seen how they've solved that. But if people think Speedy is important, we'll do Speedy. But I'm not hearing people kind of thinking it is very important yet. And I think there are better ways. Henrik, is doing some interesting stuff is like, can we actually make things faster the way we have it right now without going through all the work? We get into HTTP minimization and stuff like that. And there's a very basic proposal floating around that says, how about sending composite objects? You go into dilbot.com and you get a zip file back that contains the style sheet, and right? That way you get compression, you get domain-specific compression, and the web server can compress it once and for all. It doesn't have to do it for each transaction and stuff like that. There are some alternatives floating around, and that's one of the reasons why I'm not convinced that HTTP 2.0 is going to be a success, because I think it will be so slow that people will find other ways before that.
Yeah, I just wanted to say hooray to the thought of parallel AZ fetches. Is that something that would require moving forward on multi-protocol Varnish, or is it something that might happen while Varnish still only knows about HTTP1?
That doesn't need the multi-protocol bit. That just needs the separate thread for backend request bit. So that one would be within reach pretty soon. You have to have the magic microphone first.
Talking about ESI, what's a mechanism that you're planning to implement or thinking to implement to communicate errors in a particular ESI request?
Well, Varnish is so perfect software, we don't have errors.
Well, I was talking in the back end, actually.
The main reason why we process ESI the way we do now is that at the time it was implemented, we probably didn't realize how many resources we really have at our disposal. I think one of the things we're going to do, the next overhaul of ESI, that seems to be something that happens every some years, is probably going to offer you the option of assembling the entire result before sending it, which would allow you to modify headers and so on. There's also some thoughts floating around in the back of my head about pre-assembling parts of ESI. If you do an object and you include stuff that have TTLs that are very long, you can pre-collect the stuff you have until the lowest of those TTLs, so you don't have to do it for each request. I think that could be a very interesting computer science paper, but I'm not quite sure if it belongs in Varnish. But I will look at it, because there may be some advantages speed-wise in doing it. But I have not scoped out the next ESI overhaul yet. Don't expect it the first couple of months, for certain. I want to get I want to get the thread split done, and I want to get the streaming code and the backend if modified sends in. Both of those things have been put on hold because of the HTTP 2.0 thing that came in from the design. I want to get those done now, and that's what I'm going back home to do after this.
So for the benefit of full disclosure, so I work at Google and actually work fairly closely with the Speedy team, or I know them well. So maybe just a couple of quick comments that you mentioned. For the SSL piece, it's not mandatory in Speedy. So there are certainly people within Google and outside of Google that believe that all traffic should flow over SSL for philosophical reasons, political reasons, and so on and so forth. But the reason we use SSL specifically for Speedy is more pragmatic one. So we've had experience in the past where we've tried to deploy shared dictionary compression, even look at WebSockets today. Well, not half the time, but 10-15% of the cases, the connections just fail. A good example is your mobile phone. We can't negotiate a Speedy connection with any mobile phone, or most mobile phones. So that's one comment. I do have a question though. When you talked about HTTPS and proxies, you mentioned that you can't do that within the kind of the current draft of the HTTP 2.0 spec. And I didn't quite understand that, because you can negotiate an HTTPS tunnel to any proxy just as you would do a regular HTTP proxy connection, and then talk, like both of those connections could be over HTTPS. So maybe I missed something, but I'm curious if you could clarify that.
It may work, but as a user, you're not told where your trust extends to.
Well,
and that's why people are generally hesitant to use it. The guy to talk to there is Adrian. It's not really an issue I'm in on, because we don't do client-side proxying in Varnish. But you want to talk to Adrian about it. He can give you the spiel. But the basic problem is that the very typical scenario, to get out, you have to go through our proxy, which does legal recording or which does content inspection, whatever it does. Yep. And being able to establish trust to that and from that to the other end is not supported in the current protocol. It may actually be implemented in I think Squid actually does implement it, but since the browsers don't know how to use it.
Yeah, I think that's actually the issue today. I'm not sure if it's a protocol issue more than a browser issue. So for example, I think Chrome today is the only one that supports HTTPS proxies. I
don't know. I mean, it's not a Varnish relevant issue really, but it's one that's being discussed a lot on the working group.
Sure. Okay.
So, yeah. I can see on Hilde that we're done.
Yeah. We have to move on.